The Megalodon was not a giant great white shark. Every movie, every documentary, every museum reconstruction you have ever seen got that wrong. And a study published in March 2025 by 29 of the world's leading shark experts just proved it, definitively, using the one fossil nobody had ever done the math on correctly. The animal that comes out of that study is longer than previously thought, shaped differently than anyone imagined, and killed by something nobody expected. And the part that nobody is talking about is this. The great white shark that's swimming in every ocean right now may be the direct reason the Megalodon no longer exists. Subscribe if you want the science before the textbooks catch up. New video every week. Here is what everyone knows, or thinks they know. Megalodon was the biggest shark that ever lived. It had teeth the size of a human hand. It could reach 60 feet long. It looked like a great white, but bigger. It went extinct about 3.6 million years ago, and nobody is entirely sure why. Almost all of that is either wrong or so incomplete it might as well be wrong. Start with the shape. Every reconstruction you have seen, the Meg, every museum exhibit, every illustration in every book, depicts Megalodon as a great white shark scaled up. Wider, stockier. A barrel-chested apex predator built like a tank. That assumption wasn't based on evidence. It was based on the fact that Megalodon's teeth have serrated edges similar to great white teeth, and paleontologists assumed, without direct evidence, that the body plan matched. The 2025 study, published in the journal Paleontologia Electronica and led by Kenshu Shimada of DePaul University with 28 co-authors, demolished that assumption. The team analyzed 145 species of living sharks and 20 species of extinct sharks, building a database of body proportions, head length, trunk length, tail length, across the entire known diversity of the group. They then compared those proportions to the parts of Megalodon that have actually been found. What they found, Megalodon's body proportions are inconsistent with the great white shark model. Consistently, across multiple lines of evidence, the data points toward a body more similar to the modern lemon shark. Elongated, slender, hydrodynamically streamlined. Not a stocky barrel, a long, lean, fast-moving tube of muscle and cartilage up to 80 feet long. 80 feet. The previous maximum estimate was around 50 to 60 feet. The 2025 study raises that upper bound to 24.3 meters, 80 feet, based on a fossil vertebral column found in Belgium. That column measures 11 meters of trunk alone. When head and tail proportions are applied using the new body model, the math produces an animal significantly larger than any previous estimate. Type bigger in the comments if this surprises you. Or same if you already suspected the 60-foot estimate was too conservative. I read everyone. Here is what the 2025 study found about Megalodon's birth size, because this is where the reconstruction gets genuinely disturbing. Newborn Megalodons were already between 3.6 and 3.9 meters long at birth. That is 12 feet. A newborn. At birth, a Megalodon pup was roughly the same size as an adult great white shark. The implications of that single data point cascade through everything else. To grow a 12-foot pup to term, the female Megalodon needed extraordinary caloric resources. The animal's energy demands, across its entire life history, were on a scale that has no equivalent in the modern ocean. The study also estimates cruising speed at approximately 3.5 kilometers per hour for a large adult. That sounds slow, and it is, relative to the animal's size, but the sheer displacement of water at that size and speed, combined with a slender body that generated less drag than the great white model suggested, means the animal was more hydrodynamically efficient than any previous reconstruction implied. It didn't need to be fast. At 80 feet, patience and presence were enough. The teeth. Every size estimate of Megalodon has historically been based on tooth height, the crown height of individual teeth used as a proxy for total body length. The 2025 study found that this method introduces significant errors because tooth height varies dramatically by position in the jaw. A tooth from the front of the jaw and a tooth from the back of the same jaw can differ by several centimeters, and using either one in isolation produces wildly different size estimates. One of the study's core contributions was demonstrating that the entire dentition, the full set of teeth in context, needs to be analyzed together, not individual specimens in isolation. The largest megalodon teeth on record measure approximately 16 to 20 centimeters in crown height. That is roughly the size of a human hand. The jaw that housed those teeth, based on the new body model, would have had an aperture large enough to swallow a small car. Not a metaphor, an actual car. Type teeth in the comments if you want a full video on Megalodon's dentition and how it compares to every other large predator in history. Or body if you want to go deeper on the size reconstruction. I read everyone. Now, the extinction. Because this is where the story gets strange in a way that most coverage of Megalodon completely misses. Megalodon survived for nearly 20 million years. It dominated the oceans from 23 million years ago to 3.6 million years ago across the entire planet: North America, South America, Europe, Africa, Asia, Australia. For 20 million years, nothing in the ocean could challenge it. And then, in geological terms, it vanished almost overnight. The standard explanation in popular science: climate change cooled the oceans, prey populations collapsed, and Megalodon couldn't adapt. That explanation is partially correct, but the 2025 Shimada study adds a detail that reframes the entire extinction narrative. The rise of the great white shark roughly 5 million years ago likely played a direct role in Megalodon's demise. This isn't a new hypothesis. A 2022 study in Nature Communications, led by Jeremy McCormack at the Max Planck Institute for Evolutionary Anthropology, analyzed zinc isotopes in fossilized teeth of both species and found that their dietary ranges overlapped significantly during the Pliocene when both animals coexisted. They were hunting the same prey, the same whales, the same large marine mammals, the same fish populations. Here is the asymmetry that killed Megalodon. A great white shark at 20 feet requires dramatically less food than a megalodon at 60 to 80 feet. In a declining prey environment, which is exactly what the Pliocene ocean was becoming as temperatures dropped and whale populations shifted their ranges, the smaller, more energetically efficient predator has a decisive advantage. The great white could survive on prey populations that were simply insufficient to sustain Megalodon's caloric demands. The zinc isotope data from the McCormack 2022 study at the Max Planck Institute makes this concrete. When the team analyzed teeth from both species during the early Pliocene coexistence period, the trophic levels overlapped almost completely. They were eating the same animals, and when those shared prey populations declined, the great white needed a fraction of what Megalodon required to survive the same scarcity. The largest shark in the history of the ocean was not killed by something bigger than itself. It was killed by something more efficient, a predator that needed less to survive in a world that was offering less. Think about what that means for a moment. Megalodon didn't lose a fight. It lost a resource competition to an animal a quarter of its size. The animal that replaced it at the top of the marine food chain was smaller, faster, and metabolically cheaper to run. Evolution didn't favor the biggest. It favored the most efficient. This is the detail that every movie about Megalodon gets wrong by default, because movies need a monster, and monsters need to be destroyed by something dramatic. The real story of Megalodon's extinction is quieter and more unsettling. A slow starvation, played out over hundreds of thousands of years as the prey moved away and the competition stayed. Think of the Megalodon as a massive ocean liner designed for a sea filled with abundant slow-moving whales. The great white was a speedboat. When the fueling stations began to disappear, when the large, fat-rich whales shifted their ranges toward cooler, higher-latitude waters, the Megalodon found itself unable to downsize its caloric requirements. It was a biological dead end, a pinnacle of gigantism with nowhere left to grow and no way to shrink. There is a detail here that most coverage misses entirely. The ancestors of the modern great white were undergoing a specific evolutionary refinement during exactly this period, becoming increasingly effective endothermic specialists, capable of regulating their body temperature with efficiency the Megalodon could not match. They could hunt in cooler waters. They could sustain activity in the latitudes where the prey had migrated. They didn't just compete for the same prey. They competed for the same ecological niche with a vastly superior energy budget. And we can see the result of that competition in the fossil record directly. In geological strata from the late Miocene and Pliocene, Megalodon teeth become progressively rarer in younger layers. The decline is gradual, not a sudden absence, but a slow fade. The giant was becoming a ghost long before the last individual died. It spent its final millennia as a scavenger of its own former glory, struggling to find enough calories to fuel an existence that the ocean could no longer support. Now let's talk about how this animal actually hunted, because the revised body shape changes the hunting model as completely as it changes the size estimate. The stocky great white model implied a pursuit predator, an animal that used speed and acceleration to close on prey. A slender, elongated body at 80 feet implies something different. The biomechanics of a body shaped more like a whale shark than a great white favor endurance over burst speed. Long, slow approach, patience over pursuit. The same hydrodynamic efficiency that let whale sharks and basking sharks reach enormous sizes by filter feeding also applies to a slender megalodon. It could cover vast distances at low energy cost, maintaining cruising speeds over long periods rather than relying on explosive bursts. This matters because the prey Megalodon was hunting was not stationary. The whale and marine mammal populations of the Miocene and Pliocene oceans were themselves large, fast, and capable of sustained movement. A pursuit predator at Megalodon's size would burn catastrophic amounts of energy chasing prey that could simply outrun it over distance. A patient, long-range stalker using size, pressure wave detection, and endurance to maneuver prey into position is a more energetically viable strategy for an animal that large. The teeth support this model too. Serrated teeth designed for cutting through blubber and bone are not optimized for a high-speed collision attack. They're optimized for a deliberate, powerful bite on a target that is already within range. Megalodon wasn't ambushing prey at speed. It was positioning itself, waiting, and then delivering a bite powerful enough to disable a whale in a single strike. The nursery grounds are a detail that reframes the extinction timeline in a specific way that most coverage misses. Megalodon gave birth in shallow coastal waters. We know this because juvenile megalodon teeth, smaller, proportionally different, belonging to young animals, are found concentrated in specific shallow coastal formations around the world. These weren't random. They were nursery areas, shallow, warm, prey-rich coastal environments where females gave birth and juveniles could grow without encountering the full range of deep ocean predators. During the Pliocene, as global temperatures dropped and sea levels shifted, these shallow coastal nursery zones were disrupted. Cooling water temperatures drove prey populations into deeper or higher latitude waters that juvenile megalodons couldn't follow. The coastal formations that had served as protected nurseries for millions of years became less viable, survival rates for juveniles dropped, and for an animal that was already producing 12-foot pups at enormous caloric cost to the mother, pups that then needed years to reach reproductive size themselves, any decline in juvenile survival rates compounds across generations with devastating effect. This is the slowest possible extinction mechanism, not a sudden catastrophe, but a grinding attrition at the reproductive stage, playing out over hundreds of thousands of years, invisible in the geological record until the last adults are gone. Megalodon was a prisoner of its own biology. It chose, or rather evolution chose for it, the short-term prize of total dominance over the long-term prize of adaptability, and when the world changed, it could not change with it. The ocean is not, and has never been, a simple pageant of ever-increasing size where the biggest predator always wins. It is a game of efficiency, metabolic precision, and the ability to remain viable when conditions shift. The Megalodon failed that game, not because it was weak, but because it was too specifically optimized for a world that stopped existing. We cannot reconstruct Megalodon's sensory system the way we can for dinosaurs. No endocranial cast, no preserved soft tissue. What we can do is extrapolate from modern lamniform sharks. The great white uses highly developed electroreception through the ampullae of Lorenzini, sensory organs detecting the electrical fields of living organisms, combined with the lateral line system for pressure detection. For Megalodon, these would have been the primary hunting interfaces, not vision, an awareness of movement and living tissue that has no human equivalent, operating across the vast, dark, open ocean. Whatever that sensory system was, it was sufficient to make Megalodon the apex predator of the global ocean for 20 million years. Longer than any dinosaur lineage. Longer than any terrestrial apex predator in the fossil record. Here is what the 2025 study is explicit about. Most of what it says is tentative. Shimada himself said it directly. Many interpretations we made are still tentative, but they are data-driven and will serve as reasonable reference points for future studies. The 80-foot maximum is not a typical adult size. It's an upper biological constraint, the largest possible individual based on the largest known vertebrae, extrapolated through the new body model. Most megalodons were smaller. The average adult was probably in the 40 to 60-foot range based on the distribution of teeth in the fossil record. But the absence of a complete skeleton means that every size estimate, every body shape reconstruction, every behavioral inference is built on the same fragmentary evidence and extrapolated from modern analogues. The megalodon we have in 2025 is more constrained, more data-driven, and more scientifically defensible than the one we had in 2015. It is not definitive, and this is the detail that the wrong fossil channel exists to communicate. The most studied, most famous, most commercially exploited extinct animal after T-Rex is still, in fundamental ways, unknown. We have teeth, we have some vertebrae, we have no skeleton. The animal that these fragments belong to is being reconstructed in real time by scientists working with increasingly sophisticated methods, and the reconstruction keeps producing surprises. If you learned about Megalodon before 2025, you learned a version that assumed the wrong body shape, used a flawed size methodology, and didn't have the extinction mechanism fully worked out. The version that 2025 science is building is longer, leaner, more efficient, and killed by something considerably smaller than itself in a competition that played out over millions of years. The Megalodon of the 2025 study is a different animal than the Meg or any museum diorama you have ever seen. It is longer, leaner, and stranger. Its newborns were the size of adult great whites. Its teeth have been systematically misused to estimate its size for over a century. And the animal that may have contributed to its extinction is the same species that still patrols every warm ocean on the planet today. If you learned about Megalodon from movies or documentaries made before 2025, you learned a version built on an assumption that turned out to be wrong. The body plan, the size, the extinction mechanism, all of it is being actively revised. The study that changed the model was published 15 months ago, and most people who consider themselves knowledgeable about Megalodon have never heard of it. This is what wrong fossil exists to do. Not to tell you that everything you know is false, to tell you that the version you have is a draft and the current version is more interesting. If this changed how you see Megalodon, subscribe. Every week we do exactly this. The next animal on this channel ruled the prehistoric ocean before Megalodon existed. It had no teeth. It had a head the size of a school bus, and it was a filter feeder that somehow became one of the largest animals in the history of vertebrate life. It's right here. The Megalodon was not a giant great white shark. It was a magnificent, failed experiment, longer, leaner, and more efficient than any movie showed, and the animal that outlasted it is still out there, patrolling the same waters, having successfully navigated the very resource collapse that doomed its larger cousin. Smaller, meaner, and considerably better at surviving a world with less.